Okay, number one, the calculating projectile motion worksheet. A ball rolls off the desk at a speed of 3 meters per second and lands 0.4 seconds later. How far from the base of the desk does the ball land? How high is the desk? And what is the speed and angle of impact? So, here's our desk. And this pen's not the right one. So, here's our ball. It rolls off the desk and it lands. Okay? By this time, in projectile motion, you should be visualizing right triangles. Okay? You're always going to want to try to get a right triangle. It tells us that the ball rolls off at a speed of 3 meters per second. So that tells us our horizontal velocity is 3 and time is 0.4 seconds. Write everything that I write down and turn it in for a grade. And I am recording this, so it wants to know the delta x, how far from the base does it land? It wants to know how tall the table is, and then it wants to know the velocity in which it hits and this angle. So let's tackle the x and the y first. For A, back in the previous chapter, you know velocity is your distance divided by time. We want to solve for this, so we're going to rearrange it. Vx times time. Vx is your 3 meters per second. Your time is 0.4 seconds. This multiplied by that is 1.2 meters per second. So it lands 1.2 meters away from the base of the table. B, how tall is the table? Okay. Delta y for free fall is 1/2 g time squared. 1/2 g, you know, is 9.81. It will not change. Multiplied by 0.4 squared. If you plug it into your calculator correctly, you'll get 0.78 meters. Meters. 0.78 meters. Now, it wants us to find the hypotenuse. But the legs that we just found were the distance and the distance. It wants us to find the velocity final. So we need to find these two legs so we can plug them into Pythagorean's theorem to find the hypotenuse. So I'm going to redraw this down here to make it a little bit more clear. This is our right triangle. We said, we need to, here's the table, here's the ball that lands. So dx, the velocity in the x direction, which is this leg right here, we already said was 3 meters per second. That was a given. So that one we already have. Vy, we can calculate. From the previous chapter, Vy squared equals the square root of, Vy equals the square root of 1/2 times g times delta y. That's in free fall. Okay. We know this, and we just solved for this. So Vy is going to be the square root of 0.5 times 9.81 times 0.78. Take the square root of all of that, and your y is 3.9. So now we have We have 3.9. We have 3. We can plug these in to Pythagorean's theorem, and we can get our hypotenuse. So 3.9 squared plus 3 squared, take the whole square root of it, and if you put it in correctly, you should get 4.9 meters per second. So the ball hit the ground going 4.9. It also wants to know this angle that it hit, because it fell off the table from the horizontal down. Okay, this is parallel to this line, so this angle will equal this angle, and we want to know theta. Well, we know x, we know y. With theta, tangent theta equals the opposite, which is 3.9, over adjacent, which is 3. To solve for theta, take the tangent to the other side, inverse tangent. And if you punch it into the calculator correctly, you'll get theta equals 52.4 degrees. Now, whichever calculator you choose to use for your test, if you use the calculator on your phone or if you use one of the calculators I have in your class, you need to know how to punch in tangent, cosine, and sine, and cotangent, cosine, cotangent. You know what I mean? Inverse tangent, inverse cosine, inverse sine. So, you need to make sure you know how to punch it in correctly. You can test it by working through punching in some of the things like this to make sure that you get the correct answer. Now, number 1 is one of the longest ones. Does everybody have it?
Really fast. Like really fast. And I got lost.
Here. Y'all pass these around. Okay, number 2. In order to get all 10 of these in this period, I am going a little fast. Number 2, a slingshot is used to launch a stone horizontally from the top of a 20-meter cliff. So here's the cliff. It is 20 meters tall, so your delta y is 20 meters. The stone lands 36 meters away, so your delta x is 36 meters. It wants to know what speed was the stone launched, so it wants to know via x, and it wants to know the speed and angle of impact. So Vx is going to be distance over time. We know the delta x is 36, that's given, and the time, we need to calculate the time. What I've been calling the magic time formula is from about 3 chapters back, but time equals 2 times your vertical distance. You know your vertical distance, it's 20, divided by g, and then take the square root of the entire thing. So 2 times your vertical divided by g, and then take the square root of the entire thing. If you punch it in correctly, time is going to be 2 seconds. And I'm just going to plug that into the equation here. So 36, 2 divided by 2. So your velocity in the x direction is going to be 18 meters per second. Okay? Now, it wants to know the magnitude, or basically the final velocity as it hits. Because this is a right triangle, if you know the velocity your if you know your horizontal velocity, which we do, we just calculated it at 18, and you're able to calculate your velocity, in the y direction, you could plug those two things into Pythagoreans and find out your final velocity. So, final velocity, square root of 18 squared plus your y velocity squared. So we need to find the y velocity. Y velocity is going to be g times t, because actually the rock is in free fall. G, 9.81. Okay. Time is 2 seconds. I'm going to round this up. So I'm going to say 20 meters per second. So I'm going to plug the 20 into Pythagoreans up here. So the magnitude of my final velocity, work out Pythagoreans, and done correctly, you should get 27 meters per second. Now, to find this angle. Okay. To find this angle, I know this velocity and I know this velocity. So theta is the inverse tan of the opposite, which is the y, the 20, over the adjacent, which is the 18. And if you punch it in correctly, theta will equal 48 degrees. It's a lot of writing, but you'll be able to use this for the test. And I will model the test questions, projectile test questions, to closely resemble this problem set. That's why I'm going over it. You got it, Elizabeth? Anybody need this? Okay. Number 3. They get shorter. Number 3, a cannonball is fired horizontally from a cliff that has velocity directed at 60 degrees below the horizon when it hits the ground 3 seconds later. So here's our cliff. Here's our cannon. Okay. Cannon's fired. It says that this angle is 60 degrees.
Teacher, students, please pardon the interruption. Teachers, if you'll please release the girls' basketball team to the locker room at this time, please. All girls' basketball to the locker room at this time, please.
And time is 3 seconds. It wants to know how high is the cliff, so delta y, and how far from the base of the cliff does the cannonball land, which is delta x. So A, delta y is going to equal 1/2 g times squared. You have everything you need. You know what g is, 9.81. Time is 3 seconds. So it's 9 times g times 0.5. It's given in the question. When it hits the ground 3 seconds later, 60, yeah, this angle is 60, yes. So delta y is 44.1 meters. The cliff is 44.1 meters tall. Yes. So You know this angle. You just calculated this leg, and you want to find out what delta x is. Well, you know the tangent of theta equals the opposite, which is 44.1, divided by the adjacent. And you're solving for the adjacent. So I just rearrange this equation. Delta x equals 44.1 divided by tangent theta. In this case, theta is 60. $60 was given. So your delta x, if you punch it in correctly, will be 25.5 meters. That's the answer. Got it? Number 4. A ball rolls with the speed of 2 meters per second across the table, which is 1 meter tall. So you know it's 1 meter tall. Ball rolls, hits the ground. Upon reaching the edge of the table, it follows a parabolic path to the floor. How far along the floor is the landing spot? So you want to find delta x. Delta x is, it rolls off at 2 meters per second. So that's your velocity in the x direction. Okay, back to where I was. Delta x is your horizontal velocity times your time, multiplied by time. This is given at 2 meters per second. You know the vertical, so you can find time. 2 times your vertical displacement divided by g and take the square root of the whole thing. So in this case, time is going to be 0.452 seconds. I'm going to plug that in for there. So my delta x is going to be 0.9 meters. Five is exactly the same problem, but it's just in a different scenario. A rescue pilot drops her survival kit while her plane is flying at an altitude of 2,000 meters. So here's the plane. It's flying along at 2,000 meters. That's your x. It wants to know how far it needs to drop the package to land near the survivor. So it wants to know delta x. It's just like this one. So here we go. 2,000 meters, delta x. Oh, and the plane is going 100 meters per second. So that's your horizontal velocity. So Vx is horizontal velocity multiplied by time. So it's going to be the 100 meters per second multiplied by time. I don't know the time, but I have the vertical, so I can plug it into my time equation. 2 times my vertical divided by g. Take the square root of the whole thing. So my time is 20.2 seconds. I'm going to plug that in there. So my delta x should be 2,020 meters. So she should drop the package 200 and 20 meters before she gets to the survivor. Four and five look like two totally different scenarios, but it's asking for the same thing. Like I said, when I get done, you can come up and get these off my desk. I've been collecting them all day. Everybody have it? You're fine. Okay, number 6. Non-speckled paper here. A rifle is fired horizontal and travels 200 meters. The rifle barrel is 1.9 meters off the ground. What speed must the bullet have been traveling if you ignore friction? Okay, here's the rifle barrel. It's 1.9 meters above the ground. So the vertical is 1.9. The bullet travels 200 meters. So that's your delta X. What is your what is your horizontal velocity? That's what you want to find. So the X equals your horizontal displacement divided by time. So it's 200. We don't know what time is, but we know the vertical. So we're going to calculate time real quick. It's 2 times your vertical divided by g. Take the square root of the whole thing. So the time it takes is 0.625 seconds. We're going to plug this time into here. 0.625 seconds. So the velocity in the x direction is 321 meters per second. Boom. Okay, number 7. A skier leaves the horizontal end of a ramp with a velocity of 25 meters per second. So here's the ramp. Here's our skier. He leaves at 25 meters per second. So that's our horizontal velocity. Wants to know how far this ramp is from the ground if the skier travels 70 meters. So delta x equals 70 meters. They want to know what delta y is. So delta y is going to be 1/2 g times squared. This is back from when we did the free fall chapter. 1/2 g is 9.81 times time, but we don't know time, but we can figure out what time is. Vx is horizontal displacement divided by time. Rearrange this equation. Delta x divided by your vertical, I keep saying vertical, the horizontal velocity. So plug in 70, 25. Time is going to be 2.8 seconds. Plug that in over here. And your height is going to be 38.4 meters. Right here. Okay. I've got 15 more minutes. I got to get the last 3 done. Everybody got it? Got this one? You're fine. Okay, number 8. An astronaut stands on the edge of a crater. Okay, he throws a half-eaten Twinkie. Half-eaten Twinkie into the crater. The velocity, the initial velocity in the horizontal direction is 5 meters per second of the Twinkie. The crater is 100 meters deep. It wants to know delta X. Okay, here we go. Delta X equals Vx times t. We're using that equation again. We're given this, but we need time. Well, they gave us the vertical, so we can calculate time. 2 times your vertical divided by g, take the square root of the entire thing. And that would say it would take, well, one thing I failed to mention when I read the problem. On the moon, the acceleration due to gravity is 1/6 of g on Earth. Because of this, and because the astronaut is on the moon, when we calculate the time, instead of using g, we're using g divided by 6. So if you 2 times your vertical divided by 1/6 of g, 9.81 divided by 6, and then take the square root of the whole thing, you will get 11.15 seconds. It took 11.15 seconds for the Twinkie to land in the crater, because gravity's not as strong there. Plug that into there. You will get delta X equals 55.4 meters. Okay, 9 and 10. Different scenarios. It's the exact same problem. Does everybody have 8 done? Okay. Number 9. This will be posted. This will be posted on the Schoology page. 9. A baseball player leads off the game and hits a home run. The ball leaves the bat at an angle of 30 degrees and a velocity of 40 meters per second. So here's our baseball player, hits a home run. Okay, so he hits at a velocity of 40 meters per second. Consider this your final velocity. Okay. wants to know how long or how far did the ball travel. So if we had known the vertical or the velocity in the x and the velocity in the y, we could have plugged these two numbers into Pythagorean's theorem to get this number. But now we're going to reverse engineer this. We know that the angle that the ball was hit is 30 degrees, right? Because it was given. So we can solve these because we have the hypotenuse and we have the angle. So the velocity x is going to be the 40 meters per second times the cosine 30 degrees. And this leg is going to be Vy 40 times the sine of 30, because this leg is opposite over hypotenuse, whereas x is adjacent over hypotenuse. Okay? If I do 40 times the cosine of 30, I'm going to get this at 35 meters per second, and this one is going to be 20 meters per second. I want to find, so now I want to find my delta x. I want to see how far this traveled. So delta x is going to be my velocity in the x direction times my time. Well, I just calculated this. 35 is my Vx. My time I don't have, but I can calculate it because Vy equals gt because it's in free fall. This I just calculated to be 20. We know what g is, and I'm going to solve for t. So t, which I'm going to plug in here, is 20 divided by 9.81. 2 seconds. So plug that in over here. And my ball went 70 meters. Now number 10 is almost identical. But in this case, we have a golfer is teeing off at 170 meter par 3. So here's our golfer, hits the golf ball. Okay, it lands somewhere. Where does it land? Okay, the flag is 170 meters away. How close does the ball land to the flag? So, and we know that the initial velocity, or the velocity, is 40 meters per second, and we know it's a 50-degree angle. So in order to get to this, we need to know the velocity in the x direction, and we need to know the velocity in the y direction, and we know the angle, and we know the hypotenuse. So velocity x is going to be 40 times cosine 50, and the y direction is 40 sine 50. Opposite, this is the adjacent. So the answer is going to be 26 meters per second and 31 meters per second. Now, we're just going to plug this in. 26 times time I don't know the time, but I can calculate it because Vy is equal to GT. So time is my Vy divided by G. I've already calculated this out to 31 divided by G. So time is 3.1. Now I don't expect you to show every single step like I'm doing. I'm going to plug that into my equation, 3.1 seconds. So my delta X is 81 meters. So my ball is going to land 81 meters from where it was hit. The flag is 170 meters away. So it is 89 meters short of the flag. Cheer up, Elizabeth, that was the last one. Now, I am going to post this on the Schoology page. Please, for the remote learners listening to this, get this all written down, take pictures of it, submit it, and it's an easy 100. Do not lose this. You can use this on your test to do the projectile problems, which will look very similar to this with different numbers. Okay, thank you.